Welcome to another video. In this system of simultaneous equations, we want to solve for the value of x plus y. And we should know that x plus y here is a member of real number and as well as a complex number. So the two answers we are going to get for this, so both of them must be a member of real and complex number. Consider this as 1 and 2. So I'm going to start with question 2. Suppose we have xy equals to 35. So I want to get x first. I will make y the subject of the formula. Then we have 35 divided by x. And if this is equation 3, and let's substitute this equation 3 into equation 1. Then we get x squared minus 35 squared divided by x squared equals to 24. So we have x squared common. Instead of cross multiplying, I'm going to let x squared to be equals to any other letters. So let me choose a. That is, anywhere we see x squared, we are replacing it with a. Therefore, we have a minus 35 squared is 1225 divided by a equals to 24. So by cross multiplying and by finding the LCM, we have this as a squared minus 1225 equals to multiplying a and 25 and 24, we have 24a. And we try to collect the like terms. Then we have x squared minus 24a minus 1225 equal to 0. And here this equation is a quadratic equation because of the power of a squared. Then this equation is factorizable, and the factorization of this, this 24 is 49a plus 25a. So this 2 is 24, negative 24. And why this is bracket, if you multiply 49 and 25 together, so it's still going to be 1225 and all equals to 0. Then the two factors of this quadratic is a minus 49 and the second one is a plus 25. So if you try to expand this, we are going to get the quadratic equations we have above. So therefore, a here equals to 49 and a equals to minus 25. But here are now the final solutions. Since we assume that x squared equals to a, then we are going to substitute the value here when x squared equals to a and a equals to 49. Therefore, we have x squared equals to 49, and by taking the square of both sides, we have plus or minus 7. While for the second one, x squared equals to a, and at a equals to negative 25, we have x squared equals to negative 25. But here we have a little problem, which is this negative. So if you take the square root of the negative values, we are going to get a complex root. And that complex root is I. So which means the entire of this becomes plus or minus 5i. So we have gotten the two values of x. So which means these are the real and this is the complex. So similarly, we are going to use this for the equation 3 to get the value of y at 35 divided by x. So if the first x, let's say we have y equals to 35 divided by x, and we say at x equals to plus or minus 7. So to get the value of y, we are going to substitute the values, which is y equals to 35 divided by plus or minus 7. Then this becomes y equals to negative plus, then we have 5. So 7 and 35, that is 5. So if this is the value of y at x equals to plus or minus 7. Also, let's check for um, the imaginary part, which is plus or minus 5i. So by substituting the value of x, we have y equals to 35 divided by plus or minus 5. Then, so what I will do here is, looking at this, um, this is just like, let's say if I rationalize the denominator, so um, we are going to multiply the numerator by this denominator, which is 5i, or let me just say just ordinary I. So anyhow, but let's say I'm multiplying it with 5i, so y is also multiplying with 5i. So from this denominator, if you multiply an I and I, so that is negative 1. Then from the above, we have um, we have 5 multiplied by 5, which is the denominator, that is 25. So which means the entire of the denominator becomes minus 25. While this 5i at the numerator, it can go in 25, so which becomes 5 at the denominator. So while 5 here will also go in 35, which is in 7 times. So that is everything here becomes plus or minus 7i. So here is the value of y when x equals to plus or minus 5i. So to obtain the x plus y, it is unknown, and at x equals to if x equals to plus or minus 7 and y equals to plus or minus 5, so we got this. So y for the second one, so x plus y is also 2i for the real part. So the imaginary part is 2i and y the real part is 12i. So this is how to solve this problem, and thanks for watching. Don't forget the steps I used. Subscribe to this channel and like this video. Never stop learning.